Good morning, Madam Nazri and Dr. Azlina, as well as all the guardians in here. I am Yip Wai Chun and my team's members are Muhammad Azim, Muhammad Zuidmal, and Daniel Hakim. Today our team is ready to introduce what we have learned about Green's theorems in our course Engineering Mathematics 2. In addition, this also meets our assignments, requirements, and this is the title question we are requested to take it finished. You can watch it in details. First, we must know and understand what Green's theorem is. Green's theorem gives a relationship between the line integral of a two-dimensional vector field over a closed path in the plane and the double integral over the region it encloses. The fact that the integral of a two-dimensional convective field over a closed path is zero is a special case of Green's theorem. In other words, the physics and mathematics Green theorem gives the connection between the line integral along the closed curve C and the double integral on the plane region with C as the boundary. Green's theorem formula. This is the example of the formula that apply in the Green's theorems. Is let C be a positive on length piecewise smooth simple closed curve in a plane and let R be the region bounded by C. If G and F are functions of xy defined on an open region contains the continuous partial division. Let the closed region C be bounded by piecewise smooth simple curve R, and the function f and g have a first-order continuous partial division on the C curve, then there is the positive boundary curve of C. This is the relationship between the curve region along the closed curve C and the double integral of the region C surrounded by R. See also Green's identity. Green's formula can also be used to calculate the area of the plane figure.
Assalamualaikum warahmatullahi wabarakatuh. My name is Daniel Hakim bin Muhammad Jaiz and my number is B022110030. Okay, the Green theorem application. The double integral over the area is encompasses and the line integral of the two-dimensional vector field along closed rod in the plane are related by Green theorem. A specific instance of a Green theorem is the assertion that the integral of a two-dimensional conservative field of a closed rod is zero. A subset of the Stokes theorem, which is far more comprehensive, is Green theorem. The statement of a Green theorem that two distinct integrals form equivalent may be used to compute either type. Sometimes a line integral is transformed into a double integral using Green theorem, while other times a double integral is transformed into a line integral. So, from our research on the Green theorem, we are tasked to create an equation regarding Green theorem and apply it to solve an engineering problem. We choose to find the work done of the cellular gear in a heavy industrial machinery that have the r xy x square plus y square equal to 36, that have the force F that minus y exponent square minus cotangent y x cosec square y. Thank you.
Hi, my name is Mama Azim Sayuti, metric number B0221100074. So today I would like to present about the application of green theorems in industrial machinery, especially in gearing machine. So firstly, our question is to to find the work done when force is applied to the circular gear in a heavy industrial machinery. So, given that our question is R is x squared plus y squared equal to 36, and we need to evaluate the work done. So the first is in a component form of vector, which is negative y exponent square minus cot phi, and then x cosec square y. From the first, we can know that the f is negative y exponent square minus cot y, and g is x cosec square y. So we need to differentiate them with respect of f respect to y, while the g we need to differentiate respect of x. So the f over dy we can get exponent negative exponent square plus cosec square y, while the dg over dx we can get cosec square y. After that, we need to sketch the graph for the question. So from the question, we can get the graph is a circle shape. So circle shape with a radius, circle shape with radius 6, because from the question we know that x square plus y square equal to 36. 36 is a r square. So we need to square root of 36 and we can get the radius. So the radius is 6. So we know that the radius, the circle with radius of 6. From our graph, we can know that the limit of r is 0 until 6, while the face is 0 until 2 pi, because the shape is cover the whole quadrant, which is quadrant 1, 2, 3, and 4. So uh, we know that the face is from 0 until 2 pi. So for more clear, I generate the graph with using MATLAB software, which is I code the coding the for the software generate this circle with radius of 6, which is firstly I mentioned that the quadrant, which is the t. So I code t from 0 until 2 pi, and then I write the code for x. X is 6 cos t, and then y 6 sin t, and lastly I write the coding for generate the graph, and then the graph is generated. So yeah, that's all from me. Then I will pass it to my friends to share about the calculation. Thank you.
Thank you, Azim, for explaining the first half of the calculation. I, Muhammad Zikman, will explain about the second half of the calculation, which is the integration part. As we know, we have done the differentiation of the equation g and f with respect to x and y. From the product of those differentiation, we will need to plug in those values, which is cosec squared y and negative exponent squared cosec squared y, and we will double integrate it with the limit of 0 to 6 and 0 to pi with respect to r dr d theta, which is an area equation due to the circular motion of the gear. From the equation of cosec squared y minus cosec squared y plus exponent squared, we can cancel out cosec squared y and negative cosec squared y due to one is positive and another is negative. That will leave us with the double integration of exponent squared r dr d theta. From there, we will only need to integrate as usual with the respect of dr d theta with the limit of 0 to 6 and 0 to 5. In the end, we will get the answer 36 by exponent squared joules as in work done. As conclusion, Green's theorem can be used to simplify calculation that without it will be hard to solve, but it can only be applied to a positively oriented, piecewise smooth, simple closed curve. That's all for me. Thank you.